Good day, I am Lynn Hanave, and today I will show you my Arduino LED light display pattern. This light display pattern uses 12 identical LEDs arranged in a straight line and controlled by an Arduino. A single tap switch is used to control the sequence. When the switch is pressed, the LED pattern runs, and when the switch is released, the pattern pauses and holds its current state. I will now demonstrate how this LED pattern works. In this demonstration, I will explain how my Arduino LED pattern works, including how the code controls the LEDs in the switch. The first part of the code defines the hardware connections. This line creates an array called LEDs that stores the pin numbers for all 12 LEDs in order. Using an array makes it easy to control multiple LEDs in loops instead of writing separate commands for each LED. This next line defines the pin numbers for the tact switch. The switch is used to start, pause, and resume the LED sequence. These following variables are used to keep track of the current part of the LED sequence. Stage tells the program which phase of the pattern is currently running, such as the center out phase, the every other LED phase, or the larger spacing phases. Step is used to track progress within a specific phase, such as which pair of LEDs in the center out sequence is currently on. Offsets determine the starting point of each spacing pattern so that the program can shift the start position. Timing is controlled with these lines. Last time stores the last time the LEDs were updated, and interval sets the duration in milliseconds between updates. Using millis instead of delay allows the Arduino to check the switch continuously, so the LED pattern can pause immediately when the switch is released, rather than waiting for a delay to finish. The setup function runs when the Arduino starts. Inside it, a for loop sets each LED pin as an output and turns all LEDs off at the start. This ensures the circuit begins in a known state with no LEDs lit. This line sets the tact switch pin as an input and activates the internal pull-up resistor. This means the switch will read low when pressed and high when released. The function all off is defined to simplify turning all LEDs off at any moment. This function loops through all the LED pins and set them to low, ensuring no LED is accidentally left on from a previous step. This is useful before drawing the next step of the sequence. The main loop function runs continuously after setup. The first line inside loop checks the switch. This means that if the switch is released, the function immediately exits. This frees the LED or LED pattern at its current state. This is the pause feature that allows the pattern to stop instantly and resume later. Next, the program checks the timing. Here, the code ensures that the LEDs only update after the specified interval has passed. This creates a smooth, controlled speed for the pattern. The last time variable is updated, so the next step will happen after the next interval. Before lighting any LEDs, the program calls all off. To turn all LEDs off, ensuring that only the correct LEDs for the current step are lit. These prevent unwanted LEDs from staying on from the previous step. The program then handles the first stage of the pattern, which is the center out sequence. In this block, a for loop lights LEDs from the center outward in pairs. For example, on the first step, LEDs 6 and 7 turn on. On the next step, LEDs 5 and 8 are added, and so on until all LEDs are lit. After the center out phase is complete, stage is incremented to move to the next phase and step is reset. The remaining stages handle spacing patterns with every nth LED turns on depending on the phase. This section first sets the spacing for the current stage. The for loop lights every nth LED starting from the offset. After each step, offset increases to shift the starting LED in the sequence. When offset reaches max offset, it resets to 0 and the stage moves to the next phase. This mechanism produces sequence such as every other LED, every other two LEDs, every other three LEDs, and so on. Following the design I created, the pattern then loops back to the beginning after all stages are complete. In summary, this program creates a unique LED sequence that starts from the center, moves outward, then cycle through spacing patterns with different offsets. The tact switch allows the sequence to pause, resume instantly, and use of millis ensures smooth timing. This combination of state variables, offset, and timing make the LED pattern both dynamic and original. That concludes the demonstration and explanation of my Arduino LED pattern. I will now construct the circuit of the 12-channel LED light effect visualizer.